all of the videos are up to date and on OneNote. So if you want to watch them, go ahead. Also, keep in mind, there's actually going to be questions like this in the actual exam as well. So I wouldn't discount this as just Year 12 content. I can worry about it after the exam. It's going to be on your exam. Okay, so please make sure you're aware and you know how to do this part of the topic. So that includes everything that we've done in this Year 12 application stuff. So that just please don't think that it's just things we're learning now. It will apply as well in your exam. Okay, so last lesson, I think most of you guys were here, but if you weren't, I'm going to quickly recap on what a transformation is. Okay, so let's say you've got data, bivariate data. So transformations relate explicitly to bivariate data, not necessarily univariate. You've got your X or EV variable, you've got your Y variable or your RV, and sometimes, okay, anyone remember what might happen to the data if it's not necessarily linear? Okay, if it's not linear, what could it be? What other shape could it necessarily be? Curved. Yep, good. Non-linear. Okay, that sort of data. So if I was to put a line through this data, okay, and I wanted to make a prediction using that line, it might not be very helpful or very good because the line doesn't necessarily follow the data. Okay, if you look at it, the data is more like that. So the idea behind a transformation is so that instead of making a prediction on data that's curved like that, you want to linearize the data, make it more straight. And what a transformation does is it might change the data. So depending on what you transform, you might maybe transform the EV. So you might square this data, and it could potentially straighten out the data. Okay, so you could do that as a transformation, or you might do a transformation here where it could be a reciprocal transformation. So again, instead of this, it might straighten out the data. Okay, and data can technically come in different curves. Sometimes you'll get data that it could be curved that way. You might have data that could be curved the other way, so it could curve upwards like that. You might have data that could be curved downwards like that. Okay, it's all about data that's not linear, and you're trying to linearize it because you want to make a prediction. All right, so let's try that here. We learned about your squared transformation, so that means squaring your EV or squaring the RV. Okay, but Jordan, what do you think a log transformation is? Close your laptop as well, please, because you do not need it. What's a log transformation, Jordan? So a squared transformation is when you square the EV or the RV. What do you think a log transformation is? Sorry, say that again? Yeah, okay, maybe the opposite. It could be log. Okay, so instead of using and please make sure you close your laptop and you follow with your notes so you know what we're doing, okay? So instead of using squared, we're just going to use the log function or the logarithm function here. Now, it's pretty much the same as what we've been doing in squared, okay? It's not that hard. It's just using different things to transform your data. And if you remember at the start of this topic, there were 6 different types of transformations that you can do. Okay, so we've learned about the squared transformations, okay, where you square the data. And today we're going to learn about using the log transformation and then also the reciprocal later on, okay? So we're moving on to the second one. So please make sure you've got your calculator out as we do this. All right, so what I want you to do is I want you to put this data in your calculator, okay? In your CAS calculators. And this data is describing the immunization versus of whooping cough, okay? So and the death rate of certain countries, okay? So maybe you can assume that the higher the immunization, the lower death rate, but we don't know, okay? But put that data in your calculator, please. So we know that you need to have 2 columns, and make sure you label the columns as well. So I've done it already there, but I'll let you guys do it. Have 8 pieces of data on both columns, okay? So please double check that, and also double check that you've put the correct numbers, and double check that you've also labeled the columns. You can call them whatever you want, that's fine, but yeah, just be aware of what you've called them. Just minimize that a bit so you can follow along. So here's my data already on my calculator. And the question here is, it's asking us to linearize the data. But before we do that, I just want to make a point of why we need to do that. Because if we were to put this in a graph, so let's add this into a graph. My EV, I'm assuming, is going to be immunization rate. And my RV can be the death rate. Okay, so if you look at the data, you can see that it's not linear. It's curving downwards. Okay, so it's not, if you were to put a line through it, or a least squares regression line, and you try to make a prediction, it might not necessarily be accurate. Okay, so you want to try and make it linear, make it straight. Now here it says that it's asking us to linearize by applying a log transformation to immunization. Okay, so to the EV. So let's go back to our data. Up here, let's call it, you can call it whatever you want. I'm going to call it IMMU. Actually, I'll call it log IMMU. So we know that that's the case. Log. You can call it anything you want though. It's up to you. Okay, and then in the second row is where you do the actual transformation. So press equals, and then log, the log, and that's the log function. Open your bracket, and then whatever variable you're trying to transform, in this case it's this one, so type in IMMU. Okay. And if you've done it correctly, it should go bold. If you haven't, maybe you didn't spell it out, or you didn't write down the exact variable. Now, you might get a thing that says some sort of variable or column reference. Pick variable reference, and this should happen. Okay, on your calculator. That's what you should see. Okay, I'll do it again really quickly. So label your column, whatever you want to call it. In here, press equals. I believe this doesn't change my data. Equals, and then log, so the log, whatever the transformation is, log, open bracket, and then type in close the bracket, open the bracket, and then IMMU. Okay, and if you've done it properly, okay, it's referring to this column that you're transforming. All right. Okay, so once you've done that, what happens is, remember, we've done a transformation on the immunization rate. And look, it's linearized it maybe a little bit. Maybe there's a better transformation we can do, but let's just stick to that for now. Okay, there's my data. It is better, I would say, than that. Okay, it's a little bit more linear. Okay, in year 12 though, I think you will go through more detail as to why that's better than this. Okay, and it refers to the R value, but I won't go there today. So there's that. All right, going back to this. The question is, it's asking us to linearize the data and then write down the equation, okay, of that. So to get the least squares regression equation, menu for, so statistics, number 1, stat calc, and then linearized regression A plus BX. Be mindful of what you transformed when you put your data in here. So we transformed the log, and that's what we're using, and we didn't transform depth, but we are using it. Okay, so there's our formula. A and B. Those are the two variables that you're looking at when you're doing your equation. Okay, so let's put our equation in here. Okay, do that. Oops. Okay, let's put our equation. So remember, your equation should be y equals. Doesn't like me today. Oh, sorry. I'll stick to it. Y equals A plus bx, okay? And the only thing you're changing here is A and B for now, okay? So it should be y equals whatever A is plus whatever B is times whatever X is. And then later on after this, we do need to change X and Y, yeah? So don't just leave it as that. But for now, let's do it step by step. So I can see that A is 5340.2. Just double check, does it say to do it in a certain number of variables? It says here to round to the nearest whole number. So just double check that when you do the exam, sorry. So in this case, it's going to be 5340. Okay, we'll leave it as that. And then for the slope, or B, in this case here, okay, negative 2714.7. So we'll make it negative 2715. Okay, because they want it to be the nearest whole number. Okay, and then the last thing to do is change X and Y to whatever the EV and RV was. Be mindful again of whatever it is you transformed. Okay, remember in this case we transformed X, which is your log for immunization. So that means the actual Y variable is going to be death rate. And then you can put per 100,000 is equal to 5340 plus negative, or you can just change it to negative as well. 2715 times, remember what you transformed, log of immunization rate. Okay, and that's our formula. Okay, that is the formula. So now from there, it's going to ask us to use the equation to predict the number of death rates of whooping cough in a country if the immunization rate is 80. So again, just using this formula, okay, you're going to change X, sorry, this should be log X. You're going to change the EV to 80% and see what the RV is going to be. All right, so let's do that. So you can use your calculator for this. You can go and use your solve function. So you can go solve and then y equals 5340 plus negative, actually we'll just go straight negative 2715 times log 80 comma y. Put that in your calculator and it'll help you figure out what the death rate is. So let's put that in. Okay, so solve function. Sure, there's a shortcut to do it, but I'm cool with this. Y equals 5340 take away 2715 times. Remember, you did a log transformation on the x. So log a bracket 80, I think it was. And then comma y. We're looking for the y here. So it should be, if you get that, just press Control Enter, and there it is. Death rate 173. Does it say to round to the nearest whole number? Oops. So it should be, looking at that variable, 173.11. Cool, 173.11, which equals 173. But in this case, it's per 100,000, yeah? So 173,000. Okay, so just double check. Make sure you're reading it properly. All right. Any questions with that? I would say it's pretty much the same when you're doing a transformation on the RV. Do you want me to go through that, or do you guys kind of get it? It's the same thing, yeah? On the RV, it's the same thing. It's just this time, you got to make sure that you're logging this variable instead of the EV. Okay, so it's the same exact thing as what I've been doing here. Okay. Any questions? Okay, you're going to need your calculator for this. So Farhad and Jordan, if you want, you can share your calculator.